VigLink as a company is working in the field of content marketing. And so, like in a nutshell, what we're doing is we're inserting links, affiliated links, in the content or in the pages of our publishers who subscribe to our services. And those links usually go to product pages, and whenever someone clicks on these links, our publishers earn a commission from us. So as a part of this, we have to deal with offer records, a lot like electronic offer records, and those records are only partly structured. So we do have structured information in terms of price information, links, images, URLs and stuff, but the actual offer title, what this product, what this offer is about, is pretty much unstructured. So to give you an idea of this, we have titles such as this, like a Lucky Brand Women's Amazon exclusive, blah, 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 gene. Eventually, as humans, we easily identify that this is about a gene, but we don't have no structured information about this per se. Similarly, for automotive, we have this cheap sure key replacement, fog light, and it goes on like that. So in an offer title, we would usually see general information like how this is shipped, how the warranty works, how many pieces you get, but then also the actual product. So it's pretty important here to understand that if you buy this thing and you open the box, you won't have the chip, actually. But this is a little fog light for this chip. So it's important to understand this offer. So what is it about? What's the actual product? What's the brand name? Where would you apply it? And which parts of the offer are just not important in terms of describing the offer itself? A little bit more complicated example, but that's something we see a lot, is this one. So I already highlighted the important parts for you. First question would be, what are we actually buying if we're getting this? Are we having the iPhone, or on the left side, the speaker? Well, it's pretty important to know that we're actually buying the speaker if we're ordering this, and not the iPhone or iPad or whatever. We can infer the brand name from this title. We can infer some attributes, such as it's a wireless one, it's rechargeable and stuff, but all this is not at all structures in the original offer titles. And so this talk will go about how we're dealing with this kind of structures, how we're automatically inferring the structure, and why it is important for us as a company to do so. So there's basically two products VigLink has which are making use of NLP techniques. One is called VigLink Insert, where we are scanning we're scanning web pages and finding product mentions, and then we want to link them to our product offers. And the second product is called VigLink Convert, where we identify already inserted links and want to convert them to other offers which are identical in terms of the actual product, but where the actual publisher could earn the most commissions. So in both cases, we need NLP techniques to understand the website, to understand the offers, and to match them two together. Short introduction to the business. We've been founded in late 2008, and just about a year ago, we raised some extra funding, which helped us growing. Today, we are about 50 employees, and the service is actively used. Right now, we have about 300 million active publishers who are using our services on the demand side. And on the supply side, we have about 40,000 merchants whose offer feeds we're importing and to whose offers we can actually link to. And on a given month, we have about 500 million links where people click on. So that's a very actively used service. In terms of offer feeds, as I said before, we have this 40,000 merchants. Of course, there's like very well-known ones like Amazon, eBay, but also very tiny little merchants whose offers we have to import into our databases, then structure, and then use for the service. In the end, right now, this sums up to something about 300 million of offers, which we store locally in an Elasticsearch cluster and can then use for the two products I mentioned before. Once again, to point out where the challenges of these originally unstructured offers are, say you find the term iPhone somewhere in a website and you want to link this to your offers. Right now, we find over 500,000 of offers which, somewhere mention the term iPhone. So just linking to a product offer which has some iPhone in the offer is really not enough and will result in very imprecise offer linkings. some examples we see here. The first one is actually about a case, as is the second one. So we have a lot of accessories in our offer database, and we need to find out, is this an accessory or is this actually about the iPhone? This one is really an iPhone. It's important to identify that. And the last one is the example you've already seen before. So that's why we want to structure and understand our offers. And so over the time, what we identified is like important parts that we need or want to know about an offer, since if we know that, we can go towards structured search to solve this problem. So the first thing, of course, and ideally, is a product ID. So in this case, it would be the SVX7. That's the actual product ID identifying this specific product. A lot of offers also tell us what an offer actually is. So in this case, it's an MP3 player and a portable speaker. I would say about 90% of our offers actually have this information. So whenever we have, say, a search which is not by product ID, but more general, like show me all the smartphones, all the cameras you got, it's helpful to know what this specific product category of an offer is. We got brand names. Then we have a lot of features or attributes of offers. In here, we find it's wireless, it's rechargeable. We find colors. For fashion, we might find different stuff. So this really depends on the verticals. But usually, offers have a lot of different attributes. They are specified. And then for us, what's interesting also is like which part of this long, potentially long offer title is actually essential. So which does really talk about the offer versus, you know, like offer information such as shipping, warranty. So that's what we call the central phrase. And then there's an additional one which we call the application context, or application area. What could you use this thing for? This is especially important for accessories, because usually they mention the products you could use this for. Remember the Jeep Cherokee we saw before? We have this a lot of time with mobile phones, cameras, just because they have so many different accessories. Now, how we're getting to this structure information. We have a 3-4-step approach where, starting from the original title, we do some shallow parsing at the first level where every token is eventually classified into a different token class. On top of that, we can identify different phrases. So the two main phrases we are interested in, the central part and the application. And then as a building block in the middle, we identify the actual fields that we're interested in, such as the product or the product category. Now let's have a look into how this actually works. So the first step, it's kind of a shallow parsing, basically a segmentation task where every token or like every multiple tokens have to be assigned the labels. We identified 6 different labels which actually can describe all the offers from about 20 different verticals we are having. So the schema works both for consumer electronics as well as for automotive, or we can even use it for fashion or home and garden products. So categories, we've seen them before, product line, etc. What's interesting here is that we have something which we call an offering attribute or feature, like something is brand new, it is stylish, it comes for free, free shipping, warranty, etc. So we see this a lot, so it's important for us to recognize these phrases. And then we have functional terms, which basically have a syntactic role, like telling for what something is used, it works with, etc. So this work has been published previously, and we have some training data for that, and we basically run this as a machine learning problem using conditional random fields, because that's very similar to standard named entity recognition tasks. For those of you familiar with it, we use some pretty standard features there, such as word identity. There's some tokenization, some stemming involved. Orthographical and morphological features are very helpful, since token patterns, especially when it comes to the product names itself, they tend to have dashes, they tend to have combinations of numbers and characters. Contextual features telling us about the context of the word, what is the neighboring tokens to the left, to the right. Word modifiers show to be really helpful. Product names tend to have pronouns, articles, quantifiers. This helps us to identify all this different stuff. And as a last step, we do have a lot of lexical resources in-house because we know and learn more and more about different products. And so when you feed in this dictionary, this lexicon into the system, into the learning system, this increases performance here. So brand names, it's basically just a list. We have a lot of different product features which we already know, product categories, some products which we know, and this all goes into the model and helps identify these tags. A evaluation was done over about 20 different verticals. So it's important to see that there's a huge variety here. So this includes all the different types of products we have, starting from book names over fashion products, which are very different from automotive products, for example, just the way people specify a brand name, to consumer electronic products. You see that the performance values actually are pretty different. So there's types, for example, the brand name, where we have a pretty high performance. It's kind of straightforward to identify brand names, even though there's some pitfalls, but in general, that's more of an easy type to identify. Product names are way harder, as I said before. Between the different verticals, you have very different ways to specify product names. And then offer features are even more hard, since the variety is even higher and they're completely unstructured. So before thinking about how to improve this model and whether we have to improve the model, we need to see in how far do we have error propagation to the next step. So for now, we keep the model by this, and there's improvement to come later. In the next step, we want to use this parse information to actually see how we can infer our two central phrases, or our two most important phrases from it, and then to extract the actual fields. So to do so, we started with annotating a set, like a test set, about 200 titles. And we chose 3 of our general verticals, which is fashion, automotive, and consumer electronics. Those just because most of our products actually are from this area, and we find that a lot of our publishers actually work on these fields. And that's actually, the approach is pretty standard to first go with an annotated test set and then study the different phenomena in your problems and to see how you can actually solve this problem. Formulate a baseline approach to see where it's worth to dig into, where the real hard problems are, what the actual challenges are. So we did this and started with a pretty straightforward baseline where we could use the underlying parsing, make use of some of the tags, especially the ones, the functional terms, which help us splitting the original phrase into subphrases, and also the offer feature phrases, such as if it's about free shipping, etc. Like in an iterative approach, we split the phrase, split the original title into subphrases, and within that, we can then extract the relevant fields. And it shows that given that we have like perfect offer parses, this works pretty well. So this pretty straightforward approach gives us pretty high performance values for identification of products or product categories. And also the identification of the central phrase is at this point pretty high. However, that's based on perfect parsing. So when we go down to the imperfect parse that we actually get, we see that the numbers are dropping, and we can see where actually the numbers are dropping. So that's now for us a good hint on which level we have to improve the system. And when you remember before, we saw that the OF type, the offer featuring type, has a pretty low recognition performance. This is one reason why sometimes we have problems in recognizing central phrases. So it's a good point that after this extrinsic evaluation, go back to a step further and see where you want to improve the system. One challenge, which is not covered here, is something we call the embedded application. So remember our cheap hierarchy example, the cheap hierarchy replacement. It's pretty hard to identify that it's actually a fork light for a cheap hierarchy because, like, purely syntactically, there is no hint for this. So the only thing you can actually do is use world knowledge or some external knowledge to find out about this. Because in most cases, if it's correctly identified, we have this kind of a relation. We can see that a product is of type product category. In this case, this is purely wrong. So ideally, we have to identify cheap hierarchy as the actual application. What we can do here is, since we have a huge amount of offers, kind of reformulate the offer into a product category for an application context. That's what we see here. If we reformulate it into Foglight for cheap Cherokee and test it against our offer base, and if you find evidence for that, that's a good hint that actually here we have such an embedded application. We do this, and this seems to work out pretty well. So over time, since it's an iterative approach, we'll see refinement of the extraction of our offers. Our last step here is then normalization and subcategorization. Since what we want to do is for all the recognized product categories, since those names can be pretty long. We've got some examples here. It could be a cake baking kit. It could be a fiberglass boat. Terms can be multi-word expressions. So we want to reduce them to the actual base category. And for that, we basically make use of a dictionary, which tells us about valid and invalid categories. But since usually not all of the terms can be in the dictionary, we have to use some heuristic where we infer the head noun from the categories and then test if a head noun is a valid one. So for example, if we reduce the cake baking kit to the head noun, which here would be the kit, and we know that kit is a very uninformative term, we know that we have to step back and take the little bit longer term to not lose the information that we are interested in. So this is one step we need to do. And we need to do something similar for the attributes, since attributes seem to have a lot of different variation. For fashion, for example, we're basically interested in age groups, like is it for women, is it for kids, is it for toddlers. We want to normalize the values, and we want to group the values. Also here, we do have a dictionary which we apply, but the question is how do we actually manage this dictionary? How do we grow this dictionary? And we started to work with Word2Vec to collect near synonyms or possible terms, which we can then feed in there. And I'll show some examples where this can actually work and where this does not work. So what we usually do is we take high-frequent terms, such as the color red here, because we see that a lot of our products are red, and then we search a Word2Vec model trained specifically on fashion products here, search for near synonym terms. This works pretty well for colors. We see all the different colors. I think there's a mistake somewhere here, but in general, this helps us find a lot of things. It also works pretty well for sizes. So we have all the different spellings of sizes. It starts to become problematic for example, patterns or materials. We see there's some interesting stuff, merino and cashmere, lamb's wool, but then it mixes it up with patterns. So for right now, this is basically a suggestion system where for high frequent terms, we can find potential candidates, and we use humans to curate the dictionary and decide whether something has to go in or not. Another interesting application here is the word analogy, which is offered by Word2Vec, where you can ask this analogy questions. Small goes to S, such as large to a what, and doing this reveals that L. And this holds for these simple cases. This seems to work pretty well. If you go into more complicated cases like patterns and materials, well, we've seen a couple of interesting results for Word2Vec yesterday. We got the same weird results sometimes. It's more funny than actually useful at that point. As I said, so distance is helpful to get input for potential terms. Analogy, at this point, is more for playing with it and like seeing where the potentials are. In the end, once we did the overall extraction, we're actually storing this in Elasticsearch as some fields, and then this allows us to do a structured search on top of it. What proved helpful for us is actually to store confidence scores, like from the CRF on the token level. So we can actually search for instances which have a high confidence, especially given that now we know that especially the parsing still has some problems. But once we restrict it to something about, it's like a 90% confidence score, we usually get pretty good offer instructions. I want to show two applications of this where we can use it. One is offer clustering. So as I said before, in VigLink Convert, we are actually interested in finding similar, ideally identical offers so that we can replace them. The problem here is that we got this huge offer catalog of over 300 million offers. So like a traditional clustering approach where you would just run the clustering over the whole set is purely impossible. And the second aspect is that also pure text similarity is totally insufficient here. We learned that offers contain a lot of uninformative stuff such as shipping, warranty, etc. So you need to factor this out before you actually do the clustering. And the nice thing is once we do have the structure, we can actually run the cluster on the different fields. We could restrict to product names, to attributes, to product categories, whatever we're interested in. And to make it more feasible, we can even easily apply some blocking mechanisms. By that, we pre-select, for example, brand names and product categories. We can say, let's have a look at Panasonic headphones. This reduces it already to a very limited number of offers, in which then we can just run clustering. In this showcase, we just run a hierarchical clustering, pretty standard approach. Similarity is calculated on a feature level, on a feature basis. Here, just using a Chakar overlap measure. And this shows how actually well this already works with a pretty standard approach. So what we did is we restricted to Garmin GPS devices. That's just something we found in the offer database that we seem to have a lot about them. And we see that this nicely clusters our offers in first product lines. So there's the origin line, Vortex, Dakota, Nuvis. So these are all general product lines of Garmin. And then it groups together like different actual products, like the 650T is one specific product. And when we look into the specific offer phrase, we see that some include shipping information, warranty, some include information on which batteries you could use, etc. But working on just the important part of the offers helps to do this clustering pretty neatly. And a second application is what we call an analytics dashboard. So this helps us basically right now in-house to see what is actually in our offer database. Because before we would import a new offer feed and just not really know what's in there, since these feeds are usually huge and unstructured. And now we can have a look. What is in there? What kind of product categories is this about? What kind of brand names are we selling, etc. We're using the open source tool Kibana. Anybody heard of that tool? It's basically used in combination with log data. It works pretty well for our offer data. And it gives us pretty easy access in a visual way to our offers. That's pretty small, probably pretty hard to see. It's just a simple case where we are looking for, within consumer electronics, for a given offer feed, what are the main categories? And I'm not sure if you can read it, but we can see that we have basically batteries. Then there's cables, adapters, chargers, cameras, and then speakers. So this once again shows us how many actually accessories there are in all these products. Another application would be, let's have a look at our categories, the verticals, based on what we can earn from them. So usually what we want to see is the EPC, the earnings per click. What I'm showing here is, as a proxy, just the price for this product is. And this nicely shows, for example, that this one, which is jewelry, has on average the highest price, which is not surprising. This kind of falls down to the EPC as well. Whereas fashion, which is this one, has a way lower average price. And then once you drill in and select one of these, you can have the same overview to the different product categories. So within jewelry, for example, we have a lot of rings which sell for way more, for example, than same would hold for watches. So that's an easy way for us to understand what's in our offer databases. And the last example, that's kind of clustering per hand. So for the same example as we saw before, someone can go into the category, into the catalog, can say, okay, let's have a look at consumer electronics. Okay, Panasonic seems to be an important brand name. They have a lot of headphones. Let's have a look here. And now we see which kind of product names, actual headphones they're having. And once we select this, we see all the single product names and seeing how far they are related, if they could be used for VigLink convert, for example, to be interchangeable. Yeah. So this is how we use NLP techniques to do offer structuring. And it's currently work in progress. So I'm happy to take some questions. Okay. So you mean the parts of a product which have actually not been used for clustering? That could be done, yeah. So right now this clustering has been done on all the product features that we have. We're planning to restrict this to, say for fashion, we are basically interested in age group, maybe material, maybe sizes, to restrict it to those. So, but for now we just used all the different features we would be having.